Let's talk about building the future. But we're not talking about bricks and mortar, we're talking about code and circuits. We're going to take you inside a really special place, Robotschool Namibia, where kids are literally learning to engineer the world they're going to inherit one day.
You know, the future, it doesn't really wait around for us, does it? Just think about it. The jobs that are totally normal today, things like drone operators, AI ethicists, cloud architects, they sounded like pure science fiction just a decade ago. So what about the jobs of tomorrow? The skills we're all going to need are changing so fast. And that's a huge challenge for education everywhere.
And that brings us to the big question, right? How do you actually teach a kid to build that future? If everything is going to be built on code and circuits, how do you make sure they become the architects and not just, consumers of the stuff other people create? Well, let's dive into one really fascinating answer.
Okay, so for a country like Namibia, this whole global tech race, it's a massive challenge, but it's also a huge opportunity. To really secure its place in the world, it can't just play catch-up with technology. It's got to get ahead of the curve. And that means completely rethinking education, right from the very beginning.
And you know what? This new way of thinking isn't just some theory on a piece of paper. It is happening right now. So let's zoom in from that big national picture all the way down to a single classroom where this future is literally being put together, piece by piece.
All right, so when you picture this classroom, I want you to forget those quiet rows of desks. Instead, imagine a room that's just buzzing with energy. You hear the sound of clicking blocks, whirring motors. It's a playground. At Robotschool, the whole idea is super simple. Learning happens best when you're playing. Your curiosity, that's the only textbook you're ever going to need here.
And their method is, well, it's radically hands-on. Just look at this breakdown. A full 80% of their learning time is spent actually doing things, building, tinkering, testing. And that other 20%, it's not about memorizing boring theory. Nope. It's about discovering the why behind what they've just built with their own hands.
This whole idea is called a blended learning approach, and it's absolutely key. It makes sure that students don't just know what a sensor is, they truly understand how it works because they've wired it up themselves. It creates this powerful, unbreakable link between the why and the how. It just clicks.
So what does this journey actually look like for a student? Because it's not just random play, right? It's a really carefully structured path that guides them from that very first building block all the way to writing their first line of code.
It all kicks off with the pre-juniors, and get this, some of them are as young as 4. They're using picture-based instructions to build their first simple robots and, just as importantly, learning how to work together. Then they move up to the junior and senior levels. That's where they start coding with logic, figuring out how sensors give a robot its senses, and how to design for things like better traction. By the time they hit the advanced courses, they're programming microcontrollers, creating their own circuits, and even designing custom parts to be 3D printed. See? They're not just following instructions anymore. They're becoming real engineers.
And the biggest takeaway from this whole journey is this huge shift in how they see the world. Technology is no longer some kind of scary, magical black box. It becomes a toolbox full of parts they understand, that they can control, and that they can use to bring their own wild ideas to life.
But here's the thing. The most important things being built here aren't even the robots. Not really. It's the skills being forged inside the students themselves. We're talking about resilience, curiosity, collaboration. The stuff that's going to last them a lifetime.
And you can see the real-world impact so clearly. Just listen to this from one parent. My daughter's focus has improved. She's more curious than ever. Wow. I mean, that's the kind of personal transformation that goes way beyond any single project, isn't it?
Think of it like this. There's a human code being written right alongside the machine code. The kids learn that failure isn't the end, it's just a data point, a chance to try again. They develop this amazing curiosity to always ask why, and the teamwork skills to find the answers together. And, of course, the patience and focus to see a really tough project all the way through.
Okay, so let's zoom back out again. How does one classroom, full of kids and their robots, how does that actually scale up to impact an entire nation? Well, this is where that small-scale learning connects to a massive national vision. This program is basically a direct bridge from a child's imagination to something called Namibia's Vision 2030. That's the country's really ambitious plan to become a knowledge-based economic powerhouse. So these small robots, built by these small hands, they are literally the foundational building blocks for that much larger vision.
You can really see the whole transformation laid out here. It all starts with simple play, but that play quickly evolves into purposeful design. That initial spark of discovery, it hardens into the discipline you need to solve really tough problems. And in the end, every single one of those little student projects becomes a powerful piece of real, tangible national progress.
And all of this leaves us with one last really powerful question. What happens when an entire generation learns to dream in code? The answer to that isn't some far-off theory. It's being built right now, one robot at a time, in a classroom in Windhoek.